Hi guys, I am on page 72. This is 6D. We've got some word problems that we're going to work that use systems of equations. And in these two problems, these two examples, example 1, A and B on this page, we have to create the system of equations. So we're going to come up with two equations. That's going to be our system of equations, and then we're going to solve them. So in this problem right here, this is a real typical kind of word problem that you see on algebra tests, standardized algebra tests. The mixture problems are classic, kind of like the chart problems with the coins, the value of the coins and the distance, rate, time ones. So you've got two different containers that have different amounts of acid in them. So we're going to call chemical A, we're going to call the total amount that's in A X. And of that total amount, 60% of it is acid. So I kind of drew a little beaker and I drew a little mark that represents about 60% of it. That's the acid. And the second beaker is chemical B. We're going to call how much is in chemical B, the total amount in him, Y. And he has less acid in him. His percentage of acid is only 36%. So together she's going to create a mixture, which is my green beaker, that's going to have some of both. It's going to have 120 ounces total. So we know exactly how many ounces are in our mixture. We don't know how many ounces are in these guys over here. But in our mix, we've got 120 ounces. And of that 120 ounces, 52% of it is going to be acid. So this is a pictorial representation of what it is we're doing. We've got to create the two equations. One equation has to do with the acid, and one equation has to do with how much liquid is in each one of these that comes over to be part of this mixture. So the first equation is the easiest one. It's just X, the amount that we take from Y, the amount that we take from container A, plus the amount we take from container B is going to ultimately end up being 120 ounces. So that's pretty straightforward. The second equation is going to be based on the acid amount. So we know that of this X amount from chemical A, 60% of it, which is 0.6, is acid. And 36% of Y, the container chemical B, is also acid. And we know that 52% of that 120 ounces is going to be acid. So these are our two equations that we've set up. And probably I'm going to solve it by substitution, but I'm going to clean up this bottom equation a little bit because I think I would prefer to deal with bigger numbers, even to just get rid of the decimals. So I'm going to multiply through by 100. Remember, you have to multiply each term to get rid of that decimal point. And I'm going to have 60x plus 36y equaling 52 times 120. And 52 times 120 happens to be, if you hop on your calculator, 6240. So I've got these two equations now. I've got x plus y equals 120, and I've got 60x plus 36y equaling 6240. I'm going to use substitution, so I'm probably just going to use x equals 120 minus y and substitute him in down here. So if we do that, we get 60 times 120 minus y plus 36y is equal to 6240. When we distribute, we get 7200 minus 60y plus 36y equaling 6240. So I'm going to go ahead and subtract the 7200 from both sides. And then I'm going to collect like terms here, and I'm going to get minus 24y equals minus 960. Divide both sides by negative 24, and you end up with y equaling positive 40. Now, obviously, if you get a negative answer for either x or y, you've done something wrong, because there are not negative ounces of liquid in these containers. So now all we have to do is go back and figure out what x is going to be. So we go back up to our two original equations, and obviously this one's much easier to plug in. So we have x plus 40, which is what I think y is right here, equaling 120, and x would be 80. So our answers are x is 80 and y is 40 ounces. So on B, they're asking you just to set it up, not to solve it, just set it up. So basically, you're going to draw your picture like I did. You're going to create your two equations like we did up here. This is one of the equations, and this is the second equation. And that's all I want you to try to do for part B. And then we'll come back together and talk about it in class. Thanks for watching.